quick one, a very quick one. So we have here, this is what we got, electricity running through here, plus and minus, and the fuel, you'll need some separators obviously for the O2 and hydrogen, 2 fuel cylinders, maybe even more, and this wants to run away so that you build more and more. And then when one has run out, it switches tanks, and whilst one is being used, depleted, the other one is filling. And they're running through like a booster, like a rocket booster, I guess, on its side, that runs through a load of turbines, that then goes through a dampener, which is a multiple industrial dehumidifiers in a way, a water butt at the bottom to collect off all of that, to stop it causing an environmental problem at the end. You can dampen it down, you're making energy anyway, and you could probably repeat the system, repeat, because the more you restrict the air, the more it forces the air through. And after all, it's the movement of air at high ratio. This gas coming in, being burnt, although this one will need to be a cooling chamber here. I forgot to add that in. Because you don't want too much heat hitting into these turbines. And so this one would be more like a cooling chamber. And you just want the movement, because that pressure of air that wants to get out really quickly. It can't go out here, it can't come out here, it can't go out there. The only option it's got is to go this way. And therefore go with the flow. And as it does, you can restrict it to make it more powerful one end. These are like industrial dehumidifiers. You don't need them to have fans inside them because the airflow will push through there anyway. And then it can go through another set of turbines and just keep repeating the process. I mean, perhaps you need to add in another booster into here to push this way, to come with the airflow. So I'll pause that, I might add in another one on another drawing and then we'll see, or we'll go from there. But, you know, you can add in more boosters, especially if it starts to weaken at some point and it's not as oomphy, but it shouldn't be. It should be equal to until it reaches out. The force should be the same all the way through, give or take. But let's say it starts to, I don't know, let's say after the 5th one, it then starts to not be as pressurized. You could add in another booster, perhaps not on its side, and have another fuel line that latches into this one, and then this one adds to the push-in. I mean, this stuff's going to take its pressure anyway, so carbon wraps is also a good way. And anyway, because it's not going into space and you're not lifting it off the ground, this done under the ocean gives its own pressure versus the force out. It's possible that this could be lowered in. And once again, when the output comes, because it's already in the water, it's going to be less likely to cause a damper environment because it will have to bubble up through the ocean water anyway. Whether that's a good idea or not is another thought entirely, but this whole system could be lowered into the water and using the pressure of the ocean to hold down and add more pressure to the outside, therefore creating more pressure that you can get from this system, because it's going to be wanting to push outwards and expand and probably pop through. Maybe the ocean water will add as a pressure onto. And therefore you don't need so much in the wake of carbon wraps because you can match the forces using the ocean's depth to equal to. So, excuse me, if we have a cylinder that is able to have its, because you know you can make electrolysis under the ocean, this is pretty true, yes? This type of process can be done under the ocean. And if this is under the ocean, the pressure on this is going to be enormous. But if your fuel is pushing in, creating an equal to pressure, then therefore you can deal with the pressurization. And it won't, the ocean will be trying to implode it, let's say, the weight of the water. But because you're wanting this to push through and create turbines and turn, it will add that pressure, you know, so it's in space it's a lot more tricky with this process. But under the ocean, it isn't that challenging, to be honest. You use the pressure of the ocean, and if this is constantly burning, which I imagine it would be, because energy is a 24-hour thing, 365 days a year, But if it was on a platform that some days you're using less pressure inside pushing out, it's just the platform rises in the ocean. And then when there's more demand on the grid, it can lower deeper into the ocean to get more pressure. And there will always be that equal force using the ocean, using the pressure inside. And therefore you can always cancel out the opposite force. So the force of the pressure running through the system might be greater than the outside, let's say land level, but under the ocean, you know, you might as well use that pressure. What happens if it pops under the ocean? Well, I'm sure it's going to displace some water and it is going to move it, but once again, it's very heavy. It's very, very heavy to move all of that. It could cause more of a poof in the air than it can in the water. It's got more medium to push through. So by the time it reaches the top, depending on how deep it is, a few bubbles here, there and everywhere. So yeah, and then this system can really run away then. You can then start adding in multiple boosters into it. You can still dampen it and maybe try and get a process that's ready for space. Because after all, isn't that where everybody is heading? When this becomes too inhospitable to live on the planet, space will be the next place. So, you know, you could collect the water from here and see if there's some way that it can be purified, and using the ocean, using the energy off of some of the turbines to boil some ocean water, collect the steam, condense it, blah, 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 purify it and get rid of the salts. That will be constantly running, just like the power source should be constantly running. Maybe you need to replace the motors at time to time. Still, build two. When one's in operation, one is being serviced, the other one goes into operation and the other one gets serviced. So you can always, if you've always got two and then you've got this one running away, which I believe in the winter, there will be more demand on the energy. So where this might start to trickle at a slow level in the summer, in the winter it's going to be higher demand. So use the less days like summer to fill into more canisters. And therefore you can make enough fuel to see you through the winter. First time is always the challenge. Once you've done it the first time, your recipe is there. It's a process that works, the concept works, and then you just perfect the recipe to get it to taste right. Next year, you'll know that you'll need this many cylinders. Even if you run out, you still can predict how much you would be using at this rate, say this energy calculated versus this. So then you'll always have an understanding. The elements of salt water might be a bit of a problem. Therefore, technologies to make a new area there. Then it helps you understand how much pressure you need on the inside, pushing out versus the pressure pushing down. This gets it space ready once again. And then the fuel can either be reused. I'm not really sure it can. I'm not sure because amino acids, different stuff like this. Not sure. But it could be converted into drinking water, and if that is a ship that is giving you energy, not only is it giving you energy, it's giving you warmth, it's growing your food, and therefore it's also now making your drink, your water, and not only your water supply, this goes back into life, and then when it breaks down, you can do the same process off of the juices that come off of all of this, and therefore there is more of a circulatory system at play. And yeah, I think that is the recipe that is being mixed. And yeah, not bad, not bad. And it'll help you understand how much pressure versus this. I'm sure there will always be problems. This is very expensive to build it, I understand that. But running out of fuel and different things like that is also just as expensive because you have to find new alternate ways and different stuff like this. This might dampen down effects on the environment. I would expect that it would probably rain a lot more, probably cause thunder in different areas, but you can dampen this even on ground level just by using dehumidifiers and industrial ones. But it's going to flow that way anyway, and you just want the movement of air. Yeah, so you can dampen that whilst it's running through the process as well, and collect the water that it drops out. Put it under the ocean, it might bubble through it, and it's that's not bad. So I don't know, I was just thinking about that just now, so I thought, well, I better jot it down and make a quick video about it. But yeah, just run away, and then I wonder how many of these it can do. Can you just keep adding and adding and adding and adding and adding? versus your population expansion. It's possible. In the beginning days, it starts off with something very simple and then expands into something more complex. And hey, can it go into space? Well, yes, it can. Excellent, wonderful. Then you can support colonies not only in space. And if you found a way to reuse the water that was collected from the dehumidifiers, you might be able to get a constant fuel circulation. And therefore, it would be very strange, wouldn't it, to fill up a ship, your spacecraft, let's say, with X amount of crew members on it, fill it up with the water that you need, and run away with the cycle. How far could you get on that cycle where it just keeps recycling? I think you can get really far with that. And as long as your crew doesn't expand anymore than a certain number, I mean, in places where you haven't got water, okay, catastrophe would be if this burst. So build a shell around it in that circumstance if it was on another planet, so that, if it did pop, there was something it inflated into, and then you just collect all of that gas in an emergency system that just started hauling in the gas. So if you always had two, you'd always have the backup just in case something like that ever happened. Repair damage, see if the damage is going to be something that's going to happen repeatedly, and then fix that problem. I would do it across the whole entire thing, the whole entire system. If you ever found a problem of a breach, it would be wise that if you were to repair it just here, it would burst somewhere else, because the pressure that, having a concept, I think I'm running with a concept, you would have to replace the whole hull of it, not just a segment that popped. So if something pops and you fix that, you've taken the stress off of one part of it. There will be a new stress added to something else. Therefore, it would be wise to replace the whole thing. And then there are less disasters. And then once it's running, perfected, and then how many years has it stayed running for? I mean, that would be something, wouldn't it? Not only have we got light bulbs that have been running for about 100 years, I think, in a fire station somewhere in America. Can't be sure. That's impressive. That is impressive. But one of these systems, how long has it supported a crew for? Well, this one here, could you imagine teaching all of the kids that of 150 years from now, and this thing ran constant? Could you imagine teaching the kids that this thing has been powering generations up for this many years, up to 150 years, giving energy, giving food, giving light, giving warmth, giving energy? I mean, that's a feat. That is impressive. That would be impressive. And so I'm going to leave it there. Short and sweet, but yeah, awesome.